Hi, now we're talking to Professor Hamilton from the University of Maryland on his recent publication on the rings of Saturn. So thank you again for being here, Professor Hamilton. Could you please tell us about your publication?
Oh, well, hey, thank you. Thanks very much for having me. This is a paper on the giant ring of Saturn. We call it the Phoebe ring. It's called Phoebe ring after the satellite Phoebe, which is the source of all the ring material. Phoebe ring is really interesting. It's the newest ring in the solar system. It was just discovered back in 2009. And I was part of that team as well. And it's the same team of people who have gotten the recent results that I'll tell you about. This ring is around Saturn, and it's located it's about the furthest away you can put it from Saturn and still have it be in orbit around Saturn. So that's the main thing that's exciting about this. The new research tells us that the ring is even larger than we thought it was. In our 2009 work, we found ring material out to 200 times the size of Saturn. And that's pretty far away, much further than the other rings. And now with this latest work, we have a better image, a satellite with better field of view, and so we're able to see the entire ring for the first time. We have a picture of the ring, and you can see the debris just fading out into the distance. And so it extends about 30% larger than what we knew back in 2009. So it's absolutely immense. So that's the main finding of the paper, just that we know the full size of the ring now. The second bit is a bit more technical, and so we looked at the first question you have is, you have the largest ring in the solar system, and the first question people have is, well, how large is it? So we have that answer. And maybe the next question, well, what's it made up of? What are the particles like? And so their rings are made up of all different types of particles. The main rings of Saturn, the pretty ones that you see with the planet, those are house-sized chunks of ice and centimeter-sized particles and everything in between. So what does this Phoebe ring have? What sort of particles make up it, or give us the light that we see from that ring? And so we can actually get at that question by taking the image that we have and looking at, as a function of distance from Saturn, how bright is the ring? So we see it fading out with distance, and the details of how it fades out, that encodes information about, are these big particles, are they small particles, or is it a mixture? And so we analyze that data, and we run numerical models where we actually make up artificial rings made up of all large particles or all small particles. And we try to see which one fits the image that we have with the actual data. And so when we do this, we find that the rings composed of large particles, this actually fails to match our data. So it flips it around. The part of the material that we're seeing in the Phoebe ring, we're seeing the very smallest dust particles. And so these particles are 10 microns in size. That's about a tenth the size of the width of a human hair, very, very fine dust. And those particles are the most numerous, and they're also numerous enough to be the particles that give us the most light. And it's not reflected light. This is one extra interesting thing about this ring. This ring is made of black dust particles. And so you can imagine that's a really hard thing to spot against the darkness of space. How do you find black ring particles against the blackness of space? And the way we do this is we make use of the infrared. And so the dust grains absorb sunlight and they heat up, and they reflect very little light back to Earth. That we've never seen. But they heat up, and that energy then has to get re-radiated, re-emitted as heat. And so heat is infrared light, and we use infrared satellites to look for that. And that's what we see. We actually see this ring glowing out there. It's pretty cold out at Saturn, but nevertheless, we're seeing the heat coming off the ring as each of the individual particles is glowing. And so that's basically, in a nutshell, the summary of our research.
And so do other planets have rings like this Phoebe ring, or is this very rare and only ever seen on Saturn?
Well, it's only been seen at Saturn, but it's an excellent question because we expect that the other our planets should also have rings like this. So the ingredients that you need to make a large ring like this, the most important thing is a source satellite. So you need a satellite or a moon that's small enough that when there's things that strike it, bits of comets and bits of comet tails and things like that, that will strike the moon, and debris then is launched into space. And if a planet has small moons at great distances, these will be sources for the ring particles. And so Saturn has a very nice moon that Phoebe that does this. The other giant planets, Jupiter, Uranus, Neptune, they also have moons that should act as sources of ring material. The only difference is the difference comes about as the orbits of the moons that serve as sources. So the Phoebe moon is it's in a very uninclined orbit. The orbit's just tilted by about 5 degrees. And what that means is the ring is very narrow on the sky. It's like a little rectangle on the sky like this. And if you concentrate all that material down into a very narrow rectangle, it's brighter and easier to spot. And so at Jupiter and Saturn, rather than being narrow like this, the ring is spread out. And so all the light is spread out from this area, is spread out over this much distance. And when you do that, everything's fainter and harder to see. So we believe the other planets also have rings, but we've looked for them and we've not been able to see them yet.
Oh, that's really interesting. Just wondering, does it give us any information about the formation of planets at all? So about the satellites that are going around in a bit more detail now, but does this tell us anything more about the formation of the actual planet?
It does in a sense. It does because most rings, the particles are fairly young. So in the rings that are closer to the planets, the particles are born and they go through their lifetimes, and they basically are reaccreted onto satellites, or they collide with one another, and those timescales are anywhere from hours to maybe hundreds of years. The Phoebe ring, by virtue of its great distance from Saturn, everything's kind of slowed down, everything takes longer. And so what happens is those particles can live for millions of years, and the biggest ones can live for billions of years. So even though we see the dust grains as 10 microns in size, there are going to be bigger particles in the ring, and those bigger particles are longer lived. And so encoded in the particles that remain in the ring is sort of a history of everything that's gone on in the Saturnian system over those millions and billions of years. So we don't have enough information yet to read those clues and to know what they tell us. But eventually we will have more information, and there are clues there to learn from.
Oh, that's really exciting. You'll be a bit cheeky here. We saw recently you'd also published on Pluto. Could you give us a quick summary on that paper as well, please?
I had a very busy 2 weeks. We had 2 papers out back to back, and the Pluto paper came out first. That was probably even a bigger story. The ring is bigger, but the Pluto story is very topical because we have a New Horizons spacecraft en route to Pluto, and it's going to get there just about a month. So that results sort of summarized 5 years of Earth-based data. And so back in 2011, we discovered the moon Kerberos around Pluto, and in 2012, the moon Styx. And so those are 2 new moons, bringing the total to 5. And so what this paper talked about was just the best ground-based data, what's the most we can learn prior to the arrival of the spacecraft. And we learned all sorts of interesting things. The 2 of the moons, normally moons will keep one face locked towards their parent planet, just like the moon keeps one face towards Earth. And so we expected that for the Pluto moons as well. They don't do that. They actually rotate chaotically, which means there's no periodicity to their orbits. They go around the planet once a month or so, but the rotation doesn't have a similar period. It just kind of rocks back and forth, and they oscillate in very chaotic ways. And so that's surprising. Their shapes are not spherical. They're simply elongated. We can tell that because they get brighter and fainter with time. And that was expected. They're small enough that the gravity is not strong enough to pull them into a spherical shape. And so those are the main results, and we'll be seeing a lot more in just a month when New Horizons gets there.
That's really, really exciting. Thank you again for doing the interview. We're going to put a link to both those papers below, and I'm also going to put a link to your website. Thank you.
Thank you very much.
Bye.
Bye.